Hi friends, welcome to a co-engineer YouTube channel. Today we discuss about joint and conditional probability. Now we discuss joint probability. If your sample space consists of two events A and B which are not mutually exclusive, A and B are sample spaces are not mutually exclusive, then the probability of these events occurring jointly or simultaneously is called joint probability. In other words, joint probability of events A and B is equal or to the relative frequency of the joint occurrence. If the experiment repeats n times, then the joint occurrence of events A and B is n of AB times. Then the joint probability of events A and B is P of A intersection B is equal to limits n extend to infinity n of A B by n. Since P of A intersection B is equal to P of A plus P of B minus of P of A union B, then P of A union B is equal to P of A plus P of B minus of P of A intersection B. This is value you have to know. P of A intersection B is equal to P of A plus P of B minus of P of A union B. P of A union B value is putting like this. Then P of A plus P of B minus of P of A intersection B. The P of A intersection B value is not equal to 0. So P of A union B is less than or equal to P of A plus P of B. It is noted that probability of the union of two events is always less than or equal to the sum of the event probabilities. Now we discuss the conditional probability. What is the conditional probability? Suppose that a random experiment repeats n times and sample space contains only two events A and B. If event A occurs n of A times, event B occurs n of B times, and the joint event A and B occur n of AB times, then the conditional probability of event A given event B is equal to the relative frequency of the joint occurrence n of AB with respect to n of B as n tends to infinity. It is expressed as P of A by B is equal to the limits n extend to infinity n of AB by n of B. Here n of b is greater than or is equal to 0. Here limit n extends to infinity n of a by b by of n by n of b by n. This is the limitation property of conditional probability. Now P of A by B is equal to limit n extend to infinity n of A by B by n, limit n extend to infinity n of B by n. Here this is equal to P of A intersection of B by P of B. Here limit n extend to B of B is the value is this like this. The value is P of A intersection of B value. Now the limit of n extends to B of B's value is P of B equal to P of B is not equal to 0. That is the conditional probability P of A by B is the probability of the event A occurring on the condition that the probability of B is already known. Similarly, conditional probability occurs of B when the event A is given can be expressed as P of B by A is equal to P of A intersection B by P of A is equal to P of A B by P of A. P of A is not equal to 0. Here, from the conditional probabilities, the joint probability of the event A and B can be expressed as P of A intersection B is equal to P of A by B. P of B is equal to P of B by A into P of A. For example, if a conditional probability and probability that student will get marks between 70 and 80 is 0.154. If it is that known that the probability of marks greater than 70 is 0.6 and the probability of marks between 70 and 80 is given the probability marks greater than 70 is known is equal to a P of A intersection B. Here some intersection is nothing but the between 70 and 80 is this value. That's the intersection of this between 0.154 value by P of B. The probability of marks greater than 70 percentage is this value is major probability is 70 percentage 0.6. That's value is now the value is 0.154 by 0.6 value. Here now have to see the calci 0.154 divided by 0. 6. The value is 0.2567. This is the value of this P of A intersection by P of B. This is the condition. This is about a joint probability and conditional probability function. Thank you friends. Thank you very much.